Okay, thanks Andy for joining us on the 11th episode on machine learning for beginners. This podcast we have four people. I have my colleagues Ashutosh and Ganesh. Ganesh, who is working at the MGH Harvard Medical School as a data science engineer. We have Ashutosh, who is a graduate student at University of Waterloo, and myself, I'm a graduate student at Arizona State University. For this podcast, we have with us Andrew, Andrew Harless, who graduated from Harvard University with a PhD in economics. And he has been one of the top Kagglers working on a lot of projects related to data science pertaining to data analysis of financial and predictive analysis. And I'll hand it over to Andrew to tell us something more about himself and what kind of projects do you work on? Like, can you tell us some of your proud achievements like you have been working on, and what is the kind of data do you deal with?
Um, well, I guess the last few years I've been doing a lot of different things because I'm doing Kaggle competitions and stuff, and you get they go in a lot of different directions. As far as projects that I did on my own, the last thing, well, actually, the thing that's the thing that the project that I gave a presentation on yesterday um, was about finding the finding the tempo of a song, but finding more than one possible tempo. So if you think like you can when you listen to a song, in fact, the example that I gave was the Jackson 5 song. Oh baby, give me one more chance. I'm not a good singer, but you can you can do it at this tempo. Oh baby, give me one more chance. But the same music you can interpret it as twice that tempo. Ooh baby, give me one more chance.
Yeah.
Um, so and that so I have this machine learning model that basically uses a pretty simple convolutional neural network to analyze uh, the music, a clip of music from a song, and uh, and it compares it to a candidate tempo to see if it's consistent based on the way I labeled a bunch of songs on my own, just listening to them and deciding what tempos worked for them.
Wow, that's really interesting. I mean, I didn't have any exposure to these kind of data projects, but yeah, I was going through your resume, which says a lot of Kaggle competitions you have worked and you have won a lot of competitions. So I always wanted to ask
Well,
like
I haven't won. The only competition I won is the hackathon that I was in that Ganesh was in March at the Tangi.
yeah.
Tag. How do you say it? IITAGNE.
Uh,
And he's being humble. He's won a lot of silvers and Kaggles, and he's been like his highest rank has been like top 2-3%.
Well,
So
yeah, I've never won a competition. I've won silver medals in competitions. That's true.
yeah, that's not bad. I mean, that's much more than what we can expect of ourselves, I guess. Yeah. But yeah, I've always wanted to ask, and the whole idea of this channel was to like, because I see when I see your timeline, maybe you got started with the whole data science exploration. Even all of us were born, I mean, all three of us, like you started in maybe the late 1990s, and we were not even born. But I would,
Well,
yeah.
yeah, I mean, I never called it data science or machine learning in those days. But I mean, even before that, I was doing stuff, related to data science and machine learning, but it wasn't, the phrases didn't exist.
Exactly. That's what I wanted to like use your insights onto. Like, how do you see, how do you see this field growing? I mean, the time it wasn't even called data science, and now there's a whole hype. There are like 100K jobs available out in the Silicon Valley, and how this field had progressed. Like, what's your take on this? Like, how do you see this field?
Well, yeah, I'm kind of still trying to figure out that out myself. I guess, I hadn't, I mean, I kind of, the course of my career, I wasn't really thinking about, data science as a field because, when I started, it wasn't a field. machine learning wasn't a thing, and I didn't really think about it. And I had been doing this. Well, I'll tell this story again that I told before we started recording. That the company that I was working for, I was a chief economist at an investment firm, um, and they had kind of hobbled along for a few years after the financial crisis, and then finally ran into insurmountable problems, and they let me go. And I was looking for I was looking at job ads in LinkedIn, and a lot of them said they wanted people who knew machine learning. And I really, I can say I've done machine learning a lot before that, but I didn't know what machine learning was. I didn't know what the phrase meant. And So I took Andrew Ng's course, a Coursera course, and I realized that actually I've really been doing machine learning all along, although I was using maybe more primitive techniques than the kind, they're already much more sophisticated than what I'd been doing before, and they're now even more sophisticated than they were then, and progressing very, very too rapidly to keep up with. But
Right. So,
So I have a question. So being in the industry, what have been typical types of problems that have you faced where you need to apply machine learning, or what would be a typical scenario where, okay, this is the data, this is the processing that needs to be done, and this is the algorithms which are generally being used by the industry over the years that you have been in?
well, I guess I can tell you. I mean, the machine learning that I did before there was machine learning. The best example is probably my interest rate prediction model that I gotten my PhD, and I've been working with my thesis advisor's consulting practice for a while, and one of his other former students who now had an MBA came to me and kind of gave me the task of developing a model that would instantiate embody our knowledge of how labor markets affected interest rates. I mean, at the time we thought we knew a lot about that. I guess maybe we did, but the model actually kind of developed in a slightly different direction. But in any case, it was an interest rate prediction model. So he gave me this task of coming up with this model so that we could sell it and sell the predictions, and so I developed this model, and we spent several years trying to find somebody doing some sort of trading with a little bit of capital, and eventually that's where Atlantic Asset Management, where I became a chief economist there, and they picked up the model. But anyway, so that model was actually pretty well. It was, of course, it was a long time ago, so it was using more primitive techniques, and it was. I guess you would say that the technique that it used was an RMAX. We would technically call it an RMAX. I guess an RMAX regression, or it was. Although I didn't really call it that, but it was taking a bunch of input features that were economic data that I had processed in a certain way, and then initially applying a least squares model to get a like first stage prediction, and then putting in AR and MA terms, which to capture the time series aspect of it. So, and I don't know if that's how I would approach it if I were doing it today, because it was pretty primitive. I probably would start out with that as my baseline, actually, if I were doing it today, because of course I already have the model, and I don't know if I were starting from scratch, I guess I would still follow a similar procedure, but I probably would try a lot of fancier techniques like maybe LSTMs, networks, or I don't know. I'd have to think about like how to. I might reframe the model, because one thing about got from doing so many Kaggle competitions is like the thought that you can like reframe data in a different way. You know, it starts out, like in this case, it starts out as a set of time series. Like, you know, we had stock prices processed in a certain way, and we had interest rates and inflation rates and stuff like that. It starts out as a time series, but there might be a way to process it so that it doesn't like look like a time series anymore. I have to think about how to do that, but it's kind of, I mean, I've come to it sort of a different way of looking at machine learning from doing all these Kaggle competitions.
Andy, I had a question about how you approach Kaggle contests. So you mentioned, I mean, you have a PhD in economics, and so it makes sense. You did a lot of your initial work in finance, but off late, your Kaggle challenges have been like all over the place. Like you've done imaging. You just mentioned Friday you were giving a presentation on machine learning and music on data that was music related. So it's like all different kinds of data sets. How do you go about exploring a new data set? Like what are your first few steps that if you were just doing a Kaggle challenge today, what would your first few steps be, if you could highlight that?
Well, if I starting from the very beginning, usually when I start a Kaggle competition, it isn't like the beginning of the competition, so I can look at stuff that other people have done and get an idea. But if I was starting from the very beginning, I think the first thing I would do is like look at histograms of the features of of course it depends. I mean, if it's tabular data, then I would look at each of the data and the features and look at the histograms to get an idea of just what the overall data was shaped like, and then I guess look at the correlations between the different features, and then I might just think look at how the features are described, how the columns are described. They're not features yet really until I use them, but how the columns are described and what, like how to think about them, and think about them, try and like think about them rationally, like how is this likely to be related to what I'm trying to predict, then sometimes I could think of ways to process them to get more useful information, feature engineering kind of things. But actually, another thing that I would do a lot of with, in fact, because one thing that I would do a lot of with when I have tabular data is just take all the data that they give us without even like trying much feature engineering on it, and just take it, put it into a gradient boosted decision tree model, and play with the parameters and see if I can get. First, actually, before all that, I'm not being very clear. Am I? Before doing any machine learning, I would want to come up with a strategy for validation. So depending. I mean, if it's time series data, then you'd want to hold out a data set at the end, and because you don't want, often with time series, you get a lot of leakage if you have overlapping stuff from the same time period. But if it's not a time series, then I can do some kind of k-fold validation, but being very careful about how the folds are created, because very often there'll be things. Yeah, well, very often there'll be like categories that actually have a lot of information in them. So, like, for example, say you have data that's from people from different countries, but the country that they're from actually has a big impact on the thing you're trying to predict. In that case, if you just take each of the individuals and randomly assign them to folds, you're actually going to have a leak because you have information about the country that they came from, that is helping to make the predictions, and and that's going to be you're going to have information about a given country that's in the training part of the data, and that's going to be making predictions on the validation part that has information from the same country because it has people from the same country. So in general, when you're creating folds for a kind of k-fold validation strategy, it's important to be aware of what subcategories of the data might be correlated and might have a lot of information in those subcategories rather than just about the individual cases. But yeah, I mean, so the one thing I would like I said, once I've got a validation strategy, one thing I have learned to do is just kind of dump everything into a gradient boosting model and see if I can get a good result out of that, because actually the first featured Kaggle competition that I was in was the Sberbank Russian housing price prediction competition, and somebody put out a kernel fairly early in the competition that used XGBoost, and it did like only minimal. I mean, like the minimal amount of pre-processing of the data that you kind of had to do to make it work, to make it possible to use it, and they got pretty good results. And actually, a lot of people tried a lot of different things, and there was a lot of like kernels that came out later in terms of public kernels. In those days, they didn't have private kernels. So there were public kernels that came out, and really nobody was able to do a whole lot better than that. In fact, I think I got a silver medal in that one. I had two people working with me. I think like one of the major parts of our ensemble that ended up getting the silver medal was basically just slight variations on that original XGBoost model that somebody had put out that really had no feature engineering at all. So I mean, I guess you'd say I could take a dual-pronged approach. I mean, one is looking at the features, trying to get better features, and the other is just trying some technique like gradient boosting that can do a lot on its own, or neural networks. Although you have to be, that's more difficult for me with tabular data to know how to use neural networks properly. But just applying some technique and trying to playing with the hyperparameters, trying to get a good model out.
All right. And, what are the frameworks that you normally use for this kind of approaches? Like, what are the preferred frameworks that you use? Like Python, this one was.
Well, I tend to use Python as far as the language. I used R. There's like one or two competitions in which I had some things that I used R, mostly because I was forking somebody else's kernel that used R. But I'm more comfortable with Python, and I use I don't know. I use like the standard kinds of things like scikit-learn and pandas and NumPy and the SciPy things, and I usually use Keras for doing deep learning. Let's see what else. Well, in the last competition that Ganesh and I were in, we were using PyTorch, but I didn't really write the PyTorch code, so I kind of tweaked it a little bit, but I'm not really that familiar with PyTorch. I still usually use Keras.
Right. And I'm sure like these kind of Kaggle competitions are a great way to learn and get started with various kind of applications. But what other kind of best practices do you follow to learn these stuff, like to get yourself being educated about these stuff? I see you have completed a lot of online courses, MOOC courses on various Coursera's and other things. So like what are the best practices you keep yourself updated to these kind of research practices? Like what's new? What is your standard rule or dictionary?
Geez, I don't really have a set practice. I mean, I kind of, you know, I there's just there's so much information coming out there. I haven't come up with a like structured way to like keep aware of everything that's going on. But you know, I reading my LinkedIn feed. I see I often see like interesting things that I click on that, you know, it's some new technique or new way to use an old technique that somebody has written about. Of course, that depends on who you connect with and who you follow on LinkedIn, but um, that um, yeah. And let's see. Well, I mean, yeah, I mean, Coursera, of course, I think my overall like approach to sort of modernizing my machine learning knowledge was worked pretty well, which was, you know, basically start out start out with taking a bunch of Coursera courses and then do a bunch of Kaggle competitions, and then, you know, sort of um, you read stuff that's interesting. Um, I guess I'm not sure. I'm not sure. Like, if you're coming up as a student, I guess it's good to like connect with people and follow people on LinkedIn and maybe on Twitter who are uh, in the field, and you know, will have interesting things that they're have interesting things to link to. Um, because but I guess, you know, nowadays that there's so much going on that I get, you know, I only get like kind of a fraction of you know, the amount of knowledge that I would want to add. You know, there's and it's a lot of it is pretty haphazard, I guess. I mean, some things, when you keep hearing about something over and over again, you know it's important. So that like, for example, you know, transformers, the use of transformers in NLP is something, you know, was interesting when it first came out. I didn't know it was going to be that important, but then I kept hearing about it. And so, and I guess what most of my understanding of that topic comes from having watched uh, Rachel's videos on um, Rachel Tatman has videos on Kaggle where she goes through a paper, she goes through an academic paper. You know, they're YouTube videos, but they're on the Kaggle channel, and she'll have a series of like 4 videos on successive Wednesday. I think they Wednesday at I guess 3 no 9 not well Wednesday at 9 o'clock Pacific, I guess. I mean, I think of it as noon because I'm on the East Coast, but you know, she'll have this sort of interactive things where she'll go through the paper and people can ask questions in the or make comments in the what do you call the, you know, the little box, the chat box there. And that was kind of where I really ended up learning, well, to the extent that I know, which is still quite limited, about like how transformers work. But I think that, you know, that's I guess I wouldn't have thought that like talking about academic papers in a series of YouTube videos would be a good way to learn things. But it turns out, at least for you know, for me, it was it worked out well. It has. And now lately I'm finding a lot of things, you know, I come across stuff on YouTube. I'd sort of, you know, click on one thing and it leads to something else, and, you know, the way the internet is. And, you know, I'll see a video about some method that I didn't, either I didn't know about or I knew about, like something related to it, but I didn't really like understand how it fit together. Like today, I guess I was watching this video. Let me see if I can find that actually. If I say history. Oh yeah, this is a video. Building predictive models with feature synthesis. So someone talking about a paper, another academic paper about building predictive models with feature synthesis, and I had like learned a little bit about genetic algorithms from stuff that I did on YouTube. I mean on Kaggle, I should say, um, and but I didn't really have a sense of how genetic algorithms work. And she kind of goes through an example of it's not well, I don't know, it's technically a genetic algorithm, but it's like the same general category of algorithms, and I kind of got a better sense of how it kind of made it click for me, like how that goes together.
All right. Right. Yeah, that's really interesting. And so like if we were to like conclude this podcast from you, like you mentioned, you got started with this whole field where even before that was even had its proper names like machine learning and data science. So what would be your take on the extrapolation of this particular trend? Like where do you see this thing going, and what do you see in the next few years? Like what could be the big thing we could be laying our eyes on? Like what do you see to be the much more most potential domain of data analysis, data science, or in general any machine learning
Um,
domain?
well, I think I tend to agree with when Hillary Mason says we need to make AI boring. um, we I think there are a lot of sort of mundane applications of this. I mean, people talk about things like self-driving cars and stuff like that that are the sort of wave of the future, and I guess it's good that people are like working on big problems like that, because the even no matter how they turn out, they'll develop a lot of useful technology in the process. But I think there's a lot to be said for the direction of just applying existing techniques to sort of ordinary problems. That for example, I was at a talk the other day about this company called BotKeeper that does applies machine learning to bookkeeping, which is probably about the most boring, mundane problem you can think of. But it's still it's an area where you can apply machine learning, and I think a lot of the direction that people should think of going is like just looking at sort of ordinary problems like that and thinking about like how they can apply machine learning techniques, how they can things that are like currently done by people but don't really require a lot of human ingenuity, don't really require the sort of human creativity, I should say, that could be done by machines.
Right, right. And just like a tip for like most of the people audience for this podcast is like like junior engineers who are trying their ways out for the machine learning, getting started with the whole domain of machine learning. Like the channel says, machine learning with beginners. What would you have a tip or an advice to them? Like what kind of do's and don'ts you would really suggest them, and how what has been the best method for you to implement these things and be like being in a top position in Kaggle? Like what kind of tips would you give
Well,
to them?
well, I guess the biggest piece of advice is always be careful about validation. I mean, I might be a little too careful actually, but I still I think that it's good advice.
Yeah,
The the most important part of any machine learning problem is probably how you validate, not what technique you use.
right.
Um, let's see. Beyond that, I mean, I don't know. You know, I guess kind of like do things. Is it just to get like just do things? Um,
Getting
Work
your
on
hands
projects. This is
dirty.
what people tell me too. That's just work on projects. um, do do things. It's not so much. It's not so not as important. Like what you do is that you keep working on stuff and working on different problems
Right.
um, and as far as I don't know. Let's see. When I think about like in Kaggle competitions, um, yeah, I don't know. Trying and don't be afraid to learn from other people. Don't be afraid to borrow. That I guess that's a big thing. Um, I mean, a lot of what I've done in Kaggle competitions is like based on stuff that was originally in other people's public kernels and stuff like that, and and I use I copy and paste stuff from Stack Overflow all the time. Um, I like I guess most people, but
Yeah.
yeah, I mean it's not like don't try to go it alone. Um, I mean, unless you're really, really brilliant, I guess. But if mostly, you're going to learn. You probably learn more by borrowing from other people than you do by trying to figure out everything yourself.
Yeah, that's totally true.
Yeah.
Yeah. Yeah, that's all from my end. I mean, Ganesh and Ashutosh, do you guys have any questions, particular questions you might want to ask to Andrew?
No, no. I think that's it from my end as well.
Yeah,
Thanks Andrew,
this was
for
great, Andy. Thank you.
Okay,
Okay.
thank you.
Yeah.
yeah.
Thank you very much, Andrew, for spending the time on a weekend. I know these are one of the most freest time of United States. I would say, like getting someone on these last 2 weeks of December is something hard. So thanks a
Oh,
lot for
yes,
taking the time. And I'm sure like we'll share this video. I hope like this really helps the audience, the junior scientists who like want to work on this. And yeah, thanks a lot for having over here.
thank you.
Thank you.